Hello, everybody, and welcome to this webinar about test data management, mastering the test data. My name is Maat Urbach, and I would like to welcome all of you to this webinar. I hope you all had a wonderful Christmas holidays and that you're all fully energized to set up this 2024 with the full energy that you would love to have. Today we have a webinar about mastering test data. I will be your host and presenter. Before we truly start with the real content for today, let me do a quick introduction of myself and a little bit about DebtProf, and then we shall continue with the real content. Just to be sure, if you have any questions, please feel free to ask them in the Q&A session. I will try to answer them afterwards. Um, I have rehearsed this webinar for a few times. I'm guessing that it will take roughly a little bit longer than 30 minutes. It might take. So you will receive the recordings at least afterwards anyways. But hopefully you've got some time left and then we can discuss some of the questions and answers at the end of this webinar too. To start with my introduction, my name is Maarten Urbach. I'm one of the co-owners of DebtProf. I've been with DebtProf for over a decade right now, working especially from a business perspective and looking to test data management in that area for over a decade. So working with quite some significant experience right now and enjoying the ride ever since. To do a quick introduction, as DebtProf, what we try to achieve is our mission is that we would like to modernize the way that we approach test data deliveries. What we still see is that we still use sometimes copies, and this is not really a streamlined process. So we are really trying to make sure that test data can become an accelerator instead of a bottleneck. And what our vision is that we in the end want to be the leading test data delivery vendor, software vendor with easy to use test data management tools. Well, and what we do as DebtProf, we do it from our offices in Groningen, the Netherlands, but also from our office in USA, Miami, where we support our clients overseas from our sales and support hub that we created in Miami. From Groningen, the Netherlands, that's our technical heart of our team. So within Groningen, we have our tech team available, and we are every day working to improve our clients and the way they test data gets delivered to their low environments. So what we try to achieve on every single day is what we still also see is when software quality engineers, software developers start developing software, in most cases we still see that they use full-size copies of production databases. And it is not only for software quality purposes or software development purposes, it's also for marketing or BI purposes. And there are a couple of problems when you start using full-size copies, and that's also what we try to solve. I'm going a little bit dive deeper into the details later on in this webinar, but just quickly, you're not being compliant. You have a lack of control over test databases. Sometimes we see that clients feel like their test databases are like a ghost. Sometimes the database is there, sometimes there isn't. The problem with large databases, that's also taking it's a slow process to refresh those. And as a result of it, in most cases, people start using to create manual test data. We try to accelerate this. We try to deliver ultra compact test data sets to your lower environment. We strive to arrange effortlessly less quick test data refreshes. And we also want to make you all compliant to regulations. This is what we try to achieve with our test data provisioning platform. And I'm almost done, but our test data provisioning platform contains out of several modules. At the base of everything we do within our platform, we have DebtProf Runtime. This is our provisioning platform, and it's also our capability to automate stuff to your lower environments. On top of it, you can stack the different other modules. So you don't need all of them, then you can pick and choose whatever you need. But to explain all of them in a quick overview, and we've got DAPOF for virtualize. And DAPOF virtualize supports us in containerize databases to your low environment, so you can easily clone and snapshot these test databases. DAPOF analyze helps us to identify where privacy sensitive data might be stored, or where you can find edge cases that you can use and align with your test automation or your tests. DAPOF subset is our tool that can extract ultra compact test data sets out of a source and put them in your low environment. And DAPOF privacy on top of all of it makes sure that you will become compliant. It's our data masking and synthetic test data generation solution. Okay, with that being said, what I have prepared, and that's something I've seen, I've been in, as mentioned in my introduction, I've been in the test data management in IT for more than a decade right now, especially from a business perspective. And when I entered this IT organizations, the IT world, just after a couple of years, big data was introduced. And right now we introduce AI. And with all these different technologies that we introduce, there is one thing that they all have in common. What we in every single occasion try to achieve is that we want to make our life easier, or we will try to automate stuff that we weren't able to automate. Sometimes these new technologies are less adapted, and sometimes they are more adapted. For example, big data is adapted, but I think we expected a little bit more out of it. AI is really looking wonderful, so for good reasons, it's really interesting. But the thing is, the reason behind it is also that somehow, or what we also have been achieved over the course of the last couple of years, is that we stored more and more and more data. And that's interesting because we are now capable of storing way more data than we did ever before. And that's interesting because partly due to the fact that we are able to store more and more data, we right now can also introduce better machine learning processes, or in the end also your AI models can be better introduced due to the fact that we have all been able to store more and more data. So, and also that's also something we've seen, of course, and that's also mentioned in several reports. Data is the new gold or the new oil, whatever you like to call it. But the interesting bit is that due to the fact that we store more and more data, it also becomes a little bit more complex. And somehow we need to manage this large amount of data also for your software development and software quality processes. And the more data we store, the more interesting it gets to also get a grip and control over your test data itself. What I would like to do now is take a little bit time back in the past, because what I did in preparing this webinar or my presentation is also I figured out how did the things evolve? How did our development, test, acceptance, and production environments evolve? So when I did a little bit of research on the World Wide Web, I landed, of course, also on Wikipedia. And there's a little bit argument that you could say, but modern software development, roughly said, started around the 1980s. Software development started before, but it was mainly in between directly on the hardware itself, what I've read. But roughly around the 1980s, modern software development started. Back in those days, what probably happened if they wanted to adjust or improve their software system, they probably did it in first stages, maybe directly in production. That was perfectly fine. But when something happened, you can guess, of course, that if it's in production, something terribly goes wrong, the database or the system gets corrupted, and there's a big issue. So somewhere along the line, my best guess is that they started using a copy of production database. That was the perfect solution. So instead of doing it directly on your production environment, they start using it on a copy of production system, developing it over there, and when it's finished, deploy it on your production system. Well, and over the course of the last couple of years later, it developed into a development, test environment, acceptance environment, and production environment. Perfectly doable and perfectly plottable as well on your waterfall technologies and processes. But in the last couple of years, with also the introduction of new technology, but also new software development methodologies, we haven't been able to develop these infrastructure as well. So we introduced Agile, we introduced DevOps, we introduced CI/CD, we bought test automation tools and service virtualization tools. But somehow we tend to forget that the underlying infrastructure should also be aligned with the methodologies and the tools that we use on top of those things. And then somehow we also thought that we should introduce more complexity, big data, cloud, SaaS application, NoSQL, you name it, and everything happens. But somehow we're still using the same infrastructure. And that's why I want to discuss this today with you, because we need to master also the test data management to get the best out of all these wonderful technologies and methodologies. So over the last couple of years, we have been able to introduce a lot of complexity, which is wonderful, but somehow also business, understanding sometimes a little bit the business, they also want predictability. When we look back in time in the 1980s, I'm guessing that somewhere along those lines, when you had a real simple architecture, you probably could predict when it was finished. Nowadays, in this complex environments, the predictability of when your new release is finished becomes more complicated because we introduce more complexity. We are more dependencies between the different systems and the different processes. But then again, the business is expecting to understand when it is still finished. They're asking us the question when, especially in software development, when is the product finished? I'm asking the same question to my product manager as well, and he exactly responded in the same manner, saying it's finished when it's finished. But somehow you want to have some sort of predictability when you can go to market. And I also think that if we properly have an understanding on how test data management can be improved, that we can have a better predictability too. To make life a little bit worse, we introduced even more complexity, I would say, because next to all the different systems, the new technology that we introduced, big data, NoSQL, we also introduced more data protection regulations. It can be either cybersecurity, being that there's more cybersecurity, there have been improved hacks, of course, more advanced hacks. So we need to make sure that it's properly measurements are taken to make sure that it doesn't work anymore. We've got, of course, a GDPR or many other data protection laws that currently are in place. But we also have, that's also rather interesting, the new ISO 27001-2022. That's a renewed version of 2013, I think the latest was. That's an updated version. And with this ISO, when you re-audit your ISO certification, there's a new measurement in place, and probably your auditor will ask about it. It's about data masking. Did you have any data masking technology in place to make sure that you are protecting the data inside? So also when re-auditing on the ISO 27001, this might be an interesting case. So on a predictability level, what we of course try to achieve with everybody, and we should try to imagine if this is still possible, is when we start working as in a software quality world, at 9 o'clock you start testing an application. Somewhere along the line, at 10 o'clock you had some unexpected behavior. Either if it's test automation or manually tested or whatever you're using, somewhere along the line there was unexpected behavior at 10 o'clock. At 11 o'clock, after some discovery and some analysis, you understood that it was due to an error in the code. So the code is shipped to the developers, they make a fix. At 12 o'clock you got the fix, and at 1 o'clock you test it all over again. Perfect world, perfect scenario. This is what we try to achieve. The only thing is, and that's what we should figure out, is if the fault or the unexpected behavior also caused a change in your test data set, then not only you should fix your code, but you should also set your test data in the same state as you did when you start testing the application. So also changing the infrastructure underneath becomes more and more important. And this is a little bit what I try to achieve today with all of you. So what I will do is I will approach to help you all out in mastering test data. I will approach it from two angles, from a organizational angle and from a technical angle. To start with the organizational angle. And the interesting bit from this part is that the organizational stuff is something you can do without any tool vendor, without a software vendor. I'm guessing this is something that's the key takeaway. You can start trying to achieve this without using DATPROF, without any tool vendor. You can do it tomorrow inside your own organization. This is an internal change. So what do we need to do? Well, somewhere along the line, what we need to understand is that as an IT department, as IT in itself, we should make sure that we put the test, the software quality engineer and the software developer or software development engineer, we should make them central. These are the users of the test data, and we should make sure that we understand their needs quite well, that we understand exactly what they need and so how they can get hold of their specific test data. And somewhere along the line, it mostly shifted to other stuff, but we should make sure that we should help them to facilitate them, that they will get the test data at the right moment, at the right time, that they have it readily accessible. What happens most often is that somehow a tester, a software quality engineer or a software developer, that there are two most commonly situations from my experience. Either there is no test database available or there is a test database available. Easy situation. What in most cases happens due to pressure of a deadline, also for predictability, making sure that the software is ready, is when there's no test database available, software quality engineers start developing or manually creating their own test data. The problem that in most cases we face in those situations is that it doesn't really mimic real life scenarios. So we are testing it and we're making it sure, but when we go to production, it really might happen that there's still some problems. If we have test data available, a test database available, that's all wonderful. But there still might be some challenges available because in some cases there is a test database, but there's no data inside of it. So we have an empty table. Or it happened, this is the other one, you've got test data that's really, really old. It happened that a test database hasn't been refreshed for more than a couple of years, 5 to 7 years I've experienced in one case. So they used always some different test data just to make sure that it worked. So in some cases, it's just really old test data. It can also be the case that there's a database technology version difference. So somehow you're developing on a SQL Server 2022 and you get a 2019 database, or the data model is not in the right version compared to what you try to test. And there are multiple things that's happening, can happen still too. So even when we got a test database, we need to make sure that we can manage it properly. So somehow there's the ghost, we're still chasing ghosts. We need to get this sorted. And the solution to it all is maybe easier than you might think. And that's also one of the things, start tomorrow. What you need to do is get these people in a single room. Organize a wonderful round table and get these people into the room. So your database lead, infrastructure, your software team, either software development team and software quality team, or if they are all joined, these people and InfoSec as well. The thing is, That's also something we need to grasp, and that's something that changed also just recently within another technology introduction. What I've seen, especially after the introduction of test automation, more and more test automation tools came to the market, and that's all wonderful. We were able to automate different tests. But within the introduction of test automation, just afterwards, what I've seen is that more and more people, more and more trainings are introduced to further understand the different software languages in which you can develop. Java coding, .NET coding, all these differences have been happening. And the reason behind it is also that you further understand how you can make the test automation suite any better. So you also need a little bit more understanding on how the software works. The same applies and to databases as well. If you really want to make sure that the software quality teams get in control, they can refresh when a test database should be refreshed, then they should also have a little bit of an understanding on how a database works. Why? Because it happened too often to the database administrators that if a software quality engineer tried to do something with the database and it didn't work out properly, that the database gets corrupted. And all of a sudden, the database administrator is asked with the high priority to change it all around to set it back into the right state. And this is something that a database administrator dislikes. And the problem is it happens only because there's a lack of understanding on how a database works. So what we also should address during these meetings with these people is discuss also with the database team. Think about how you can get it under control, and also are okay with training and understanding what's happening in the database when you change certain things. The infrastructure lead is also really helpful because you also can understand and how can we develop an architecture and infrastructure that works in our software development pipeline within also using the databases. And of course, InfoSec is needed because they need to address when you have done enough for data protection regulations, for example. So with that being said, that's a little bit the organizational stuff. I hope that that's a key takeaway. Just starts tomorrow because that can be done. You don't need a technology vendor for it as well. On a technical level, there's also some things that we need to address, of course. And what I try to do is explain it in the end, at the end of this slide or this presentations, to give you a little bit of more insight in how you can master the test data with some case examples. But let me first do a little bit on the technical level. What we should try to achieve is also within what I highlighted at the beginning of the test data, the person that started developing or testing the application. What we need is we want to have a magic test data button. If we click on the test data button, we have exactly the right test data available in our lower environment, in the test environment that we need. That's something that we try to achieve with our customers and what you also should aim for in the end. But the question is, what's lying behind this test data button to make this work? Well, I've created a real simple decision tree behind it, and there's also some technology stuff that's behind it that you should solve, but let me start with the decision tree. Simple first question is that you should ask yourself is, do we need to do something on a data protection level? Do we store privacy sensitive data? Do we have competitive information that we want to protect? Or is that not the case? If the answer is yes, you need to do something with data sanitation, data masking, data scrambling, data obfuscation, synthetic test data generation. All that is covered in my decision tree as data sanitation. If that's successful, then you can provision it to your lower environment. Easy decision tree. If it's unsuccessful, you will do it all over again and just make sure that it works, because we also need to convince our InfoSec people that if data protection is an option that we should master, that we can send an audit report with successes to our InfoSec department. If there's no data protection needed, then you can start to think, how can we provision test data to your lower environments? All said and done, now we can discuss how can we provision test data to our lower environments. A couple of case studies or cases that I would like to highlight. Case one, compliancy. Let's start with compliancy. In most cases, we also see that customers of ours start with this question. We need to get compliant. And then what also, of course, is the problem or the issue is we want to receive test data, should be predictable, and we should count on it. Well, the easy and the most simple and effective way is we will mask it and it's all done. So now it's masked. There's a small line, a little bit small to see, but it's there, and I will send you the slides afterwards. But it's masked, so now you can still test. Easy done. This is done in a couple of minutes, so wonderful, no problems, and you can integrate it in your CI/CD pipeline. Unfortunately, it's not always the case. Sometimes it's also nice that we introduce a limitation. This is a real life limitation, so sometimes masking data sanitation takes over 36 hours. So it's taking 36 hours. How can we address this situation? Because especially if you want to master it properly, we also need to know how we can introduce it into your agile pipelines or your CI/CD pipelines. So we need to master it. We need to rethink how we do stuff. So, well, I introduced some additional complexity right now, but it's easier said and also easy to explain what happens over there. So we've got a production database now introduced. What we do is we make a copy, a golden copy. And the thing is, this is a scheduled task. So when everything is scheduled, we have our database that's masked still available, so you can test it properly. That's all done. But due to the fact that we can schedule in our golden copy environment the masking job, we can just let it run for 36 hours. And when it's done, we can just deploy it into our lower environment. All done. This can be rather quick, and everything is just wonderful. Still, really simple conceptual thoughts. I understand that in real life it can be way complex, so I introduce a little bit more complexity in this slide, but I also understand it's way more complex than this. But just from a conceptual perspective, this is how you can master it. So now you've got it all set, you've got a database introduced, but of course, it's not a single database. We have been introducing, of course, a lot of complexity over the last couple of years. So we have multiple systems that work in concert with each other to get the proper results. So we have got another system as well. So if our biggest system just takes over 36 hours, we do it in our golden copy. If we have other systems too, related systems, that can be done in a real quick throughput time. So we can schedule it when we just press our test data button. All done. It can be different, and then we have to rethink, but this is also a little bit the tailor-made issue that we try to cover with our customers. I understand that I'm almost already running out of time, but I will finish my presentation and I will send it afterwards. And I have a couple of slides left, so if you're interested, just keep there and I will be almost finished. So the second case is compliancy with subset. The thing is, the provisioning of test data to the lower environments, this golden copy to the lower environments, it still takes too much time. And we also need to save costs on these lower environments. The business is also asking, we need to address some of the costs. We are heavily investing in IT, but we also need to manage the cost also in the software quality area. So, same picture as we did before, and the issue right now is the throughput time from that golden copy to that lower environment takes more than 2 hours. The test data button still works, but it's too slow. The reason can be all different kinds, but most commonly there are two issues: sheer size of the databases we want to store more and more data, or the complexity. If we just take a glance at sheer complex or sheer size, what we can do is, because when we reduce and make ultra compact test data sets to these lower environments, we can save cost on these lower environments too. And if you have multiple of those, the cost savings are increasingly heavily and more if you have more of these environments. But with our subsetting technology, we can create a subset process. So instead of working with 10 terabytes of data, you only work with 100 gigabytes. You can deploy it in the cloud, you can deploy it on premise, you can deploy it wherever you want it to be. And this process can sometimes be within a couple of minutes. It still be rather complicated because due to the difficulty in a data model. So sometimes it takes also up a couple of hours. Still not really what we like to achieve. But then again, we understand how it works. We can schedule this task. So this task of subsetting can be done in our golden copy environment. And then we can deploy really small, compact test data sets to your low environment really quickly, really efficiently. And this is a real streamlined process. So with a press of a test data button, you now have small test data set masked available in your test purposes. This can also be done consistently over multiple systems too. So this can work, but then it takes some time, but this is how you can master your test data with every single step. So you can mature when you started with masking, and then you can take the next couple of steps. Last case is masking and database virtualization. You can also introduce subset to the equation too, but for now, masking and database virtualization. The interesting thing is, with database virtualization, is you can create a golden copy, and based on this golden copy, you can quickly and easily create snapshots or clones of the database without introducing a much higher need of storage. So this virtual database can read and understand what's happening in the golden copy, and it delivers the same results as a full-size copy. The reason why it's so quick is because we don't have to copy all of the data from that golden copy to that virtualized instance. It's just reading it. So what's happening underneath is that we just store only the deltas. And that makes it really fast and efficient. So this is something you can also address, and especially if it's really big, or if the creation of the virtual databases become still large, or you want to reduce the golden copy, which it can also be the case, then the introduction of subset could be even more beneficial. So quickly how it works. This is also what's happening. If you have a containerized database, you can deploy it to your lower environment and the virtualized instance. We don't copy the full data, it just understands it, and it only stores the deltas. So you understand, and you can also time travel in between the different deltas or to the original one too. And with that being said, I would say that you have a lot of insights in how you can gain more information and more knowledge, and how you can master your test data so it can be aligned with the infrastructure that you will need, and to make sure it also works with your agile software development and your test automation efforts. With that being said, I'm at the end. If you have any questions or anything, we share some knowledge on our LinkedIn pages too. These are our contact details, so please feel free to contact us. You can also do it directly. So if there are any questions, I would love to answer them. I will take a glance to the questions in a short while. But if you don't have time and you need to leave, just feel free, send your email, your questions via my email address. I will try to answer them.